For today's lesson, our focus standard comes from Grade 7 Expressions and Equations Standard 4. Use variables to represent quantities in real-world or mathematical problems. Our topic is from our unit Simplifying Expressions and Equations, Translating Words into Expressions and Equations. Our essential question is, how can we use math symbols to translate words into math sentences? Please take a moment pausing the video if you need to copy down the topic and essential question in your header, along with today's date, sub your question column and your note column, and resume the video when you're ready to begin. So today's skill is not one that's brand new. Translating words into math sentences is something you've done for a while now. So here are just 3 reminders for translating word problems to math sentences. Some numbers may not be necessary. Remember, we refer to that as number hunting, so you want to be careful of that. And some may be written out, so really make sure that the numbers and the values you're using are necessary to the problem and you didn't miss any that were written in word form. The word than is a turnaround word. It changes the order of how the sentence is written in math. So we write it in one particular order, and we use that word in English. When we translate that to math, we have to be careful. And as always, with most problem solving in mathematics, diagrams can be very helpful. So with that, let's go ahead and get started. Here's our first problem. In preparation for a meeting, Mrs. Bond places a basket of fruit on each table that has apples, bananas, and oranges. There are 7 tables. Write an expression to represent how many pieces of fruit Mrs. Bond has for the meeting. So I'm going to let you think about that. Can you draw a diagram? What do you think that's going to look like in mathematics? And I'll give you a hint. We're going to use A for apples, B for bananas, and O for oranges. So, one thing, if we're thinking about a diagram, we could imagine that we have the 7 tables, right? So 1, 2, 3, 4, 5, 6, 7, right? So we have all 7 tables. And then we know that on each table there is some number of apples, bananas, and oranges. Right? So A for apples, B for bananas, and O for oranges. We don't know anything else about them, how many we have or anything like that. So we just know that there's a basket on every table that has apples, bananas, and oranges, and that there are 7 tables. All we have to do is write an expression. And so we could say, and just put parentheses around this, and know that if I wanted to know the total number of fruit for one table, I would just add up the number of apples, A, plus B for the bananas, plus O for the oranges, right? And just add it up, that'd be the total for one table. But I want to know it for 7 tables, so I'd multiply this by 7. So, if we are to translate that into mathematics, the expression would be 7 times the quantity A plus B plus O, where these represent the fruits, the total in one basket, times the 7 baskets placed on each of the 7 tables. So there's our first one. Let's go ahead and try our second problem. Here we are talking about Corey and Nora, who collect comics books. Nora's collection is 4 less than 2 times the number of comic books Corey has. Use C for the number of comics books Corey has to write an equation for how many comic books Nora has in her collection. So, the equations, we kind of want to focus on what are we doing. So, what are we specifically being asked? An equation for Nora, right? So we know it's going to be N equals. We also know that because it says Nora's collection is. Any form of the word is is usually meant to be the equal sign. So Nora's collection is, right? Kind of translate that first part. And then we start to see some of the numbers that we're dealing with. 4 less than 2 times the number of comic books Corey has. So there's some more important information to use C for the number of books Corey has. So this is just going to all be a C. So it looks like I've just scribbled all over the page, but hopefully you can see I'm trying to highlight a few things. So we're really going to focus on this phrasing here. 4 less than 2 times the number of comic books Corey has. We have to be careful of this turnaround word right here. Than, and I'm going to say specifically less than. So what does it mean to have less than somebody? What do you do if you have less than something? What operation? Well, we subtract, right? So we know that if I have less than something, we're going to subtract it. Because it's that word than, that's a turnaround word, it's at the beginning of the sentence, which tells me it's going to come at the end of my math sentence. So she has 4 less, so I would subtract 4. So we've dealt with this phrase up to here, and it says 2 times the number of comic books Corey has. We're using C for Corey's collection because we don't know how much he has. So I'm just going to put that in my sentence here, and you guessed it, 2 times that, so we can just write it as the term 2C. So Nora's collection is and equals 4 less than 2 times the number of comic books Corey has. Well, if I take 2 times the number of 2C, doubles that, right? That's the 2 times. And here's that 4 less than. So I think we got the equation right here. So we are going to go with that equation. Nora's collection is 2C minus 4. Let's go ahead and try our third and final problem. Adriana is trying to figure out the area of a rectangle. She knows that the long side is 2 inches more than triple the length of the short side. Using S for the length of the short side, write an expression for the length of the long side. Then write an equation to help Adriana find the area of the rectangle. So I'm going to have you work on this one, but I'm going to suggest that you start with a diagram, right? So imagine that we have this rectangle here, and see if you can go through using some of the information from the last problem to see how far we can get with writing an expression for this length of this long side in comparison to the short side, and then put that all together in an equation. Well, I would start out by knowing that we're using S for the short side, and on my rectangle, this is my shortest side. And then she knows that the long side is 2 inches more than triple the length of the short side. So we have that more than, that turnaround word here. So 2 inches more, so I'm going to put plus 2 at the end. And triple the length of the short side. Well, I have S for the short side, and if I want to triple that, I'm going to multiply it by 3. So triple the length of the short side plus 2, because it's more than triple the length, and that gives us the dimensions of our long side. So far we've done that first part. The expression for the long side is 3s plus 2. And now, since we're needing to find the area, we need to be able to multiply this length times this length. That's how we find the area. So the expression for the long side of that rectangle, as we showed previously, would be 3s plus 2. So the equation for finding the area, we talked about it, but here would be the official forms. You could say the area is equal to the short side times the long side, so use parentheses for those two things. Or if we use our work from using the distributive property, I can multiply s times each thing here and come up with the equation a equals 3s squared plus 2s. So that is going to conclude our video for today.